G'day and welcome to the first video on Markov Chains. This continues our series of discrete random variables, and this time we're looking at Markov Chains, which is 8.5 in your textbook. So for this I'll jump into an example straight away and show you what Markov Chains sort of signifies a little bit later. We have this first example of lean or podgy. Each week this fictitious character Fred weighs himself, and if his mass is less than 75 kilograms he declares himself lean or thin. Otherwise, Fred declares himself to be podgy. So if he weighs more than 75 kilograms, he's podgy. And I don't really know how to spell podgy because I do it inconsistently. But anyway. Now, if he is lean one week, he has a 40% chance of being lean the next week. That's probably because he eats lots of cakes and, yummy goodness. But if he is podgy one week, then he has a 30% chance of being podgy the next week. Probably because he goes out running and does all sorts of exercise. So he doesn't want to be podgy 2 weeks in a row. So what I'm going to do is I'm actually going to display this information on a chain like this. We can call this a Markov chain. It's not really a Markov chain, it's just a visual diagram that I like to put. So I've got lean over in, this is the first week over here. So I've got to actually write first week, and this is the second week. Okay, so if he's lean one week, he can either be lean the next week or podgy the next week. So it's 0.4% chance, sorry, 40% chance, or 0.4, he will be lean the next week, and therefore 0.6 of him being podgy the next week. Over here, this is kind of the key to it. Stays lean, goes podgy, or if he's podgy, he has got a 30% chance of being podgy again the next week, or a 70% chance of being lean. Okay, and those are all of the outcomes that can happen based on each week. So if Fred is podgy this week, what's the probability that he will be lean in 2 weeks' time? Okay, now you can do this a variety of different ways. I prefer to use a tree diagram because I believe that's the easiest way of doing things. But I'm going to use this little chain here every single time so that I don't forget what's going on. So I always set this up first. So if Fred is podgy this week, okay, so we know that he's podgy this week. So podgy, what's the probability that he will be lean in 2 weeks' time? Let's set it up. So next week he could be either podgy or lean, and at 30% and 70%. The next week he could be either podgy or lean, But I actually only want to know what the probability that he'll be lean in 2 weeks' time. So I can cross out these two outcomes here because I don't want to know those ones. So he can either go from podgy to lean, or he can go from podgy to lean. Okay, either way he ends up being lean. So 0.3, and then to work out this one, it's the same, 0.3 and 0.7. To work out this one here, I go back up to my diagram and I'm like, okay, so he's lean. It's either lean or podgy the next week. I can get all of these numbers here, and I end up getting 0.3 times 0.7 plus 0.7 times 0.4, which ends up being 0.49. So if he's podgy this week, he's got a close to a 50% chance of being lean in 2 weeks' time. Okay. Here's another way, or an alternative way of calculating the same answer. This time we're going to use matrices. And if I've got my calculator, I would probably use matrices. If I didn't have my calculator, I probably would use the tree diagram that I showed you before. So what I'm going to do is I'm going to set up a matrix to display this information. And so I've got this little grid here. This is last week and this is next week. So last week he was lean. What's the probability he'll be lean next week? Well, that's 0.4. If he's lean this week, what's the probability he'll be podgy next week? Obviously 0.6. So those two numbers here have to equal 1. If he's podgy this week, what's the probability he'll be lean next week? That's 0.7, and therefore that one has to be 0.3. So those two numbers there have to equal 1. It doesn't matter what they add up going across, it just matters what they add up going down. And then I'm going to put this information here directly into this little matrix here. And what I would have to do if I was drawing this matrix, I'd have to indicate which one is which. So I would probably have to say up here is lean and this is podgy, and then I've got lean and podgy here, and I would have to somehow signify that this is this week and that's next week. Okay, if you don't, I don't know what this matrix means. But if I've done that, I put 0.4 and 0.6, 0.7 and 0.3. I would encourage you to write this table first and then just copy this table across like this. And this is what we call the transition matrix, okay, where n is the number of weeks or times that it changes. So if we were going to work out the value for the answer for B that we were looking at before, if Fred is podgy this week, what's the probability that he will be lean in 2 weeks' time? We know the answer is 0.49 because that's what we worked out in the previous question. We can now use this matrix. So 0.4, 0.6, 0.7, 0.3, all to the power of 2. Okay, so a transition matrix, we're going to, there's 2 weeks it's going to change. And when I do that on my calculator, I end up getting this matrix here. Now, this is why it's so important to actually write down what each one of them is, because otherwise you don't understand what the matrix spits out. I might just quickly do this on my calculator just to show you what happens. So I'm going to do the matrix of 0.3 and 0.7. Is that, no, I think it was 0.4 and 0.6 and 0.7 and 0.3. Let me just check that, make sure that's right. Yeah. Okay, and I'm going to do all that to the power of 2. I don't know what that is unless I've drawn it in my drawn it before. So that matrix there, that means that I will be from the start. If I'm podgy this week, that means that in the week that I'm looking for, or next week, it will be 0.49. So podgy to lean is 0.49. That's the probability that I'll get. That's the answer that I'm looking for. But if I was asked, lean to lean, then that would be 0.58. Hopefully that makes a little bit of sense. You can also use this approach down here. Okay, so I can use this transition matrix that I've got here, and this just kind of signifies what each one of them is: lean to lean, podgy to lean, lean to podgy, or podgy to podgy. All multiplied by the probability that he was lean in the first week or podgy in the first week. So for me, that transition matrix is still the same as before. 2 is the number of transitions or changed, and I knew that he was podgy in the first week. So therefore, it's 100% chance that he was podgy in the first week and 0% chance that he was lean in the first week. This is what we call the initial matrix, this one just here. Okay, what he was initially. And I knew that he was initially he was podgy. So if I pop that in on my calculator, I know that he was initially podgy. I put that in and I end up getting these 2 values here. And again, you just need to know which one's which. The top one is podgy and the bottom one is lean. Okay. No, sorry, completely the other way around. I did know that actually. This one here is lean, this is podgy, so therefore the answer up the top will be lean and the answer down the bottom will be podgy. So that's like the, finally after all the transitions, after all the changes, after all the weeks, that's the probability he'll be lean, that's the probability that he'll be podgy. Okay, so hopefully that has helped you understand how to do the matrices in reference to Markov chains. In the next video I will kind of explore this a little bit more and hopefully we get a sense of what Markov chains is all about.